Number 3. A force acts on a cube of mass m that accelerates upwards along a vertical frictionless surface. The magnitude of the force is F and it acts at theta to the vertical. What is the magnitude of the acceleration of the cube? Now, so that's the diagram we've been given there. Mind you, the question is telling us that the cube should accelerate up. Now, the cube has a mass we are given in the question to be m. Gravity acting on m should give us the weight of the cube, which should be directed downwards. Now the force that is acting on the cube, the question is saying is inclined at theta to the vertical. We don't need a force inclined at an angle to the vertical. We need a force that will be parallel to the weight that we've denoted there as W is equal to mg. So we resolve. When we resolve, we get the force to be F cos theta. Okay, those are two parallel forces. We don't use F sin theta because it is perpendicular to the weight. We need the force that is parallel to the weight. Now, because the weight and then the resolved component of the force we need are moving in opposite directions, the net force which should provide the acceleration should be a subtraction between those two forces. Mind you, weight is a force. So the net force should be a subtraction between the two because these two vectors are moving in opposite directions. But because the object ends up accelerating upwards, we do not subtract F cos theta from the weight. Rather, we subtract the weight from F cos theta. So we write that the net force we need to accelerate the object or the cube up is given as F is equal to ma. So acceleration there is given as force over mass, and the force we have there is our net force. So that our net force is F cos theta minus weight divided by the mass. So when we simplify, we are getting A is equal to F cos theta minus mg divided by m. So if we look through the possible answers we have here, first one is F cos theta minus mg over m. Definitely that's our correct answer. So without having to go down and look at the other answers, our correct answer in this case is A.